think was better than physics.
I always knew I wanted to be a scientist. You know, that was something, you know, when I was even before I went to school, I was playing with things like Meccano. I like making things.
So I kind of thought, okay, kind of sounds a bit physicsy, a bit chemistry, I'll give that a go.
I thought materials for me was better than physics because I didn't want to lose the chemistry element. I really did enjoy chemistry, I liked it, and I didn't want to lose that, and materials let me keep hold of both elements of it.
There's a lot more to play with. That's what I liked about it, because I've always been quite creative, so it kind of fitted in nicely. The definition of material science I always give to people who don't know what it is the study of materials and their properties and why they have them. So looking at the microstructure of a material to see why it has particular properties, and then using this knowledge to design new materials.
Materials is a lot more applied than physics. Like physics is sort of a lot of blue sky thinking and, oh, this is interesting, let's say that, whereas materials it's much more connected to engineering, so everything's much more applied. If it won't give you something interesting or something useful at the end of it, we don't bother studying it.
In the first year, it's very much what I call the issuing of the toolkit. Everybody's doing the same courses. You're learning the basic concepts. In the second year, is where those concepts are put more to work.
Your third year, you do entirely options. So you choose what you do and you choose what you study, and then you go to particular exams based on what you've chosen. What
makes the Oxford course unique, I think really unique, is that unlike most other materials courses, it's a 4-year course, and the 4th year is spent doing a research project. And I mean the whole 4th year is spent doing a research project in one of the research groups.
I'm thinking of studying more along the sort of composite side and maybe the polymers and rubbers and things, but I do want to look into metals and metallurgy, which is a really big part of material sciences.
We've got the fixed practicals in place. I do one practical every 2 weeks where I have 3 days, usually it only takes 2 to do an experiment, and then I have a week to write it up and hand it in.
Like any science, it's quite heavy. You have a lot of contact time, you do a fair amount of work, and yeah, it's a fairly heavy workload, but if you balance your time right, it's manageable.
Lectures, I generally, on average, have about 11 or 12 a week.
An awful lot has to be packed into what's a very short term. The terms are 8 weeks, and there's a lot of new concepts we expect people to catch up on very quickly.
The facilities at Oxford for materials are quite extensive. There's your college always has a library with all the books you need, and your tutors buy books in for you. There's a departmental library as well, and an overall science library.
The lab facilities are really, really good. There's some stuff here in ways of electron microscopy for materials, other specialised techniques. We're the world leaders in something called atom probe tomography, which is taking things apart atom by atom and seeing what they're made of. Lots of things like that are absolutely as good as you'll get anywhere, and of course, because of the way the course is structured, the students get to use these.
Oxford pay for a subscription to all the magazines and all the journals, and you can always go online and look at them and look at any articles, which makes research a lot easier.
We've got very good contacts with a wide range of industries, and a lot of our students do internships in the summer vacations in UK and companies generally.
I found tutorials quite strange. I've never been in sort of a group of 2 and a teacher before, and it was quite a strange experience, but it was quite nice because you suddenly have this sort of vast store of knowledge in your tutor in front of you, and you can sort of ask them lots of questions, and you can learn so much in an hour. It really surprised me how much you can learn in one tutorial.
It's up to the students to make their own way. I mean, the tutorial system, of course, you see your tutors once a week and discuss things with them, but outside of that time, it's much more, I think, up to the students themselves to make their own way than perhaps they're used to at school.
I do most of my work with other material scientists in the library, so you work quietly for about 20 minutes and goof around for about 5 minutes. And it's a good way of dealing with it rather than shutting yourself away for 6 hours and just doing a cheap sheet straight away.
When you talk to the undergraduates in a tutorial, and they're excited as well, and every time I meet a new group of students, that energy seems to fire up again, and that's great. What we want to find out in the interview is simply, is this person going to do well in this subject at Oxford?
I had 3 interviews. They were quite taxing. Like, it was an hour of talking to tutors, and they would ask you questions, and you'd ask another one and another one. It does take a lot out of you, but they were quite interesting. They were quite fun as far as an interview can be.
What we do in the interview is try and find each year 1 or 2 slightly unusual problems relevant to materials science, relevant to physical sciences generally, where to get some way with it, the student has to work out how to do it as well as just doing the problem.
And my second interview, I hadn't covered the topic that they questioned me on.
If they ask a question and you know the answer straight away, that's a bad question for them. They want to see you struggle, they want to see you think about it and move you and try and see if they can move you towards the right answer.
The interviews we're trying to get somewhere like what the atmosphere would be like in a tutorial, so we can see how people would perform, how they would do, how they would learn in that kind of teaching system. I think we're looking for people who are good, obviously interdisciplinary scientists. That means people who don't want to be particularly in the box of just being a physicist or just being a chemist or just being an engineer or biologist, but somebody who likes all kinds of different sorts of science and wants to make it work together.
Do chemistry, do physics, as much of it you can. I'd advise you to do further maths as well, but it's not essential. There are people here that haven't done further maths and they've done just as well as anyone else.
You've got to be interested in finding out why something does something, and not in a vague way. You want the specifics, you know, the nuts and bolts. You know, in a material science sense, this is what the atoms, the crystal defects, the structure is doing that controls the behaviour, and not being happy until you've actually got the right answer. I think the kind of students who come to do this course and who graduate in it, because they're very good at solving interesting, not too well defined problems, they find lots of different things they want to do, and they find lots of different companies or career paths, you know, where that can be employed.
Once I've finished the undergraduate course here, I'm thinking of maybe doing a postgraduate course, or maybe going into a graduate programme at a company like Rolls-Royce or somewhere similar to that.
I like the idea of management.
An awful lot of students, of course, who go on to either do further research here or elsewhere, or who go on to do not just material science, but scientific type things in industries. You know, I've had several students who've got a degree and gone to work at Rolls-Royce, at aerospace, for engineering consultancies. Quite a lot of our students, surprisingly, go into jobs in finance, because we've produced people, or the people who come through the course are in that problem-solving mindset, especially where the problems aren't that well defined, that is actually very useful in those kinds of careers. And of course we have some people who do the kind of careers you just wouldn't expect at all. One who went off to be a field researcher for Lonely Planet, one of my students who runs his own brewery somewhere in Norfolk, and one who's gone into, I remember, some kind of music production. I mean, it isn't restrictive. I mean, the message number one, I think, is if you want to do this course, then if you don't apply, your chances of getting in are actually zero. So, you know, we want people who want to do this course, who want to do science well, to apply. And I think that's the only message.